All right, we are live on X.
All right.
And are we live? Are we live on YouTube?
It matters less.
That's true. Someday it'll matter, but today it does not. But it'll be a nice it'll be nice archival recording.
There we
So
go.
we are officially live, my friend. Welcome to the Martian Engineering Mars Cast,
Totally didn't invent that name just now. Yeah.
featuring you and I. Maybe we could start by you introducing yourself and what is it that you do here?
Yeah. So I'm Josh. I'm a owner of Martian Engineering with my partner Ted. He'll come up later. I've been developing software for about 17 years, done a string of startups. Am now enjoying not being venture backed or having investors, and instead just doing work with AI on a variety of different code bases, both greenfield and existing, because it's fun. We just write a lot of software here, and we have a lot of fun doing it. That has lately transitioned into doing a lot of open source development because we have found ourselves building an increasing amount of tooling to augment our own development processes. And OpenClaw became a big part of that at the start of this year. And our, especially my open source arc has leaned heavily that direction. So, yeah, there's a little
And
overview.
And I am Jacob, and I am an engineer also at Martian Engineering. And I am the intern running the live streams and X feed. So if you have any trouble with them, shout at me. Doing my best, but stuff ain't easy. Um, but yeah, really enjoying. I think this is a wonderful time to be a developer. These tools just let you move a lot faster and jump into different stacks where your general programming information, your programming knowledge helps you be very effective, even if it's a language or a library that you don't know super well. So that's been a lot of fun for me. Um, but what we came here to talk about today is, of course, lossless claw or lossless context management. Um, and I think we should start with the exciting news, which is, I believe, it is now easier than ever to get.
Yeah, for the last, I think, couple of weeks now, time has been weird lately. It's just a thing you can install through the normal OpenClaw plugin installation process. So it's just a npm package. You run a command, it installs it. You set up some config, and it works. Which is different than how it used to be, where you had to run off of a custom branch of OpenClaw that I had to keep up to date about every 5 minutes to keep up to date with the pace of OpenClaw development. Those times are behind us, and now it just works. So it's very easy to get set up using.
So in order to implement lossless claw, you had to make a context management plugin system, right? So that people can put in different context managers. And then OpenClaw or lossless claw is the first one of those. Is that kind of how it works?
Yeah, yeah, because like in hindsight now, it's kind of surprising that context management is actually just not a thing that people have experimented with very much. Every agent does it more or less the same way, which is they have a context window. It's the LLM's context window. It fills up. They leave a budget at the end of it so that they can take that conversation that's happened so far, summarize the whole thing, and replace all the messages with a summary. It's called compact. It's sort of like the most naive way you could do this. This is what Claude Code does. It's what Codex does. It's what every major agent does. It's what OpenClaw does because it's based on Pi, another coding agent that does it the same way. And so lossless context management is an alternative way to manage an LLM's context window. And no one had really done an alternative way before. And so OpenClaw had no built in way to swap out the default behavior with an alternative one. And so, I didn't want to jump straight to, hey, OpenClaw, let me submit a big PR that totally reworks the entire way you do compaction. I thought that probably wouldn't be appreciated, probably wouldn't end up landing because it'd be a big change. And I know that OpenClaw is designed to be pluggable. They are encouraging very actively a move towards plugins to decrease the amount of code that OpenClaw has to maintain itself. So they want the whole system to be more modular. And so it seemed pretty natural to me, okay, we just need to extend that plugin interface to support alternative context management systems. And if, the fact that we came up with LCM is cool, and I think it's great. I think it's the best way you can manage context right now. But there should be more development in the space, and there certainly will be. And so it seemed like a pretty good idea to have a general purpose way to foster that experimentation by supporting pluggable context engines.
And in OpenClaw, is it kind of using just a very kind of the same standard compaction cycle that,
and it still
Claude
does by default.
Okay.
Yeah. Your context window fills up, gets too big, it runs compaction in the background when it gets there, or you can manually trigger it. And then your agent gets kind of dumb. It kind of remembers what you're doing, but only kind of. And
this is especially a pain point with a long-running agent like we expect from OpenClaw compared to like in a coding agent like Claude Code or Codex. You might be using it to just develop a feature. And maybe you go through a couple compaction cycles, but then you might throw that session away and you're done with that, and you'll be working on something else. But with OpenClaw, like these agents, you expect them to kind of just live for indefinitely. So they're going to go through many compaction cycles, and you don't want them to reset to dumb every time.
Yeah, that's right. It's a totally different surface area. And this might be a good point to kind of back up and tell the story of how all this started, because we did not invent, or I did not invent lossless context management. It's my partner Ted, actually. Yeah, let's talk about this for a minute. So my partner Ted is working on a new startup right now called Vultropy. And he has a partner there named Clint, who is a bit of a polymath, computer scientist, amongst other things. He came up with the idea for lossless context management. And he and Ted, in this accelerator they're in called HF0, they built it out over the space of a couple of weeks, and they published a paper on it. And they built it with a fork of OpenCode. They call it Volt. We now maintain that. And so they kind of prototyped this as a coding agent. And I went and met up with him back in mid-February, and he was telling me about this. This was before the paper had come out. They'd had the prototype working, and he was telling me about it, giving me access to the coding agent. And I was deep in the weeds on playing with OpenClaw at the time. And he was, more deep in the weeds on working on a startup. Hadn't gotten the chance to, invest the, 3 weeks of energy into getting OpenClaw tuned the way you wanted it and working. But I had. And so my initial reaction to LCM was, well, we need this for OpenClaw because this is a much better fit for the reasons you just mentioned, Jacob. This is meant to be a personal assistant that gets to know you and is long running. You coding agents, by contrast, you tend to treat them kind of as ephemeral things. You run many of them, and each one is for a specific task. And when you're done with that task, you close it out, you start up a new one. It isn't really meant to have a broad focus on a variety of different things over, even over days. So like that's usually the longest you'd have a coding agent session open for is, maybe a couple days for something really big, but then you close it out and you're done. Whereas with OpenClaw, you have one agent that's just running on an ongoing basis that you talk to for weeks or months, only months at this point because we're like 4 months into OpenClaw. But it's a very different model, and a better way of managing context just makes a ton of sense for that. And so he gave me access to Volt. I immediately downloaded it and started working on how I would bake this into OpenClaw. And that came together over the course of about a week and a half, maybe 2 weeks. Can't remember. Anyway, that was where I focused immediately. And over the course of that, I came up with a lot of improvements to LCM because using it in OpenClaw battle tested it in a way that you wouldn't really see in a coding agent. And so I was running many, many millions of tokens through a single Claude context window, a single session. And so that surfaced a whole bunch of issues with the implementation that I built on and improved on. And it's still very closely tied to the original idea that they put forth in their paper about LCM, but productionized a bit for actual usage. And that's what became Lossless Claw.
And now that we have that, we have agents that just are a little bit smarter and remember what they've been doing and don't get dumber over time. Don't get dumber with every compaction cycle.
Yeah, it's definitely not perfect, but the most notable thing you get when you run it is you never notice that kind of amnesia that suddenly happens after compaction, where you have a lot of context, you're in a zone, you're working on something, it feels like you're in tune with what the agent's doing, then compaction happens, and then you have to reestablish that because it forgot a bunch of things. And with OpenClaw, you experience this the most distinctly because you often context switch between a bunch of different things. One minute I'm doing something for work, I'm exploring a new idea. Another minute I'm taking a picture of a jury summons I got and having it calendar that in for me. And then I'm jumping back and forth between different things. And I, maybe I want to reference something that happened yesterday or the day before, and it just has no awareness of that because it's out of the context now. That doesn't happen anymore with Lossless Claw. You just never experience that sudden drop in cognitive ability.
And I wonder if we'll start also if it might become useful to start running longer running coding agents too, with lossless context management built into a coding agent. Because I know for myself, if I'm working on the same startup for a while, after a couple of years, I might circle back to something and be like, oh yeah, I remember why I made these decisions. I wrote this last year, but I have some context for it. I'm not just looking at the code with fresh eyes. And maybe it'll make sense for an agent, that develops a big detailed context about a project over time using lossless context to not throw that all away and to have that as a bit of a knowledge base. We'll
Yeah,
see as we get more experience using it.
I think you could totally do that. You could do it today with Volt, the original agent that Volterby made. Like I mentioned, that we now maintain that because I kind of took LCM and ran with it, and Ted and Clint at Volterby, they're focused on other things. Their big focus is on decreasing the cost of training models. This was more of a side project for them. And they were pretty happy to find out that I was really excited about this and wanted to run with it because they actually needed to focus on other things. And so they transferred ownership of Volt to us. Another engineer at Martian, Eric, he's taken over stewardship of Volt, and we've updated it to employ a lot of the practices that we developed while working on Lossless Claw. And so you can use that now. It works. If you've used OpenCode, it looks just like OpenCode because it's worked from it. We have ongoing plans for that. We'd actually like to, and we'd like to see lossless context supported by the other major coding agents. In fact, Ted made a fork of Codex that has this built in. Unfortunately, Codex doesn't accept pull requests, so we don't really have a path to upstream that. But I think as people realize how much leverage there is to changing the default way that compaction happens, this will start to become a more mainstream thing. And in the meantime, we're focused on the open source coding agents like Volt, the original with its open code base, we've also talked a lot about extending this to the Pi coding agent as well, because we like Pi. Pi's cool.
All right. Well, before we get too much further into this, I think now might be a good time to kind of talk about how this works and like what lossless context management is. Because we're using the same LLM models as everybody else, right? We got the same context window. I think it's 1 million tokens now for the latest codex as everybody else. So, like, how can you never lose context if you have a limited context window? Like, that doesn't make sense. Like, how do you solve that?
Yeah, exactly. All right, I'm going to put up a screen share that Jacob will add into our talk
Oh,
here shortly.
I see. Okay.
Because
there's a button I need to hit. There we go.
Yep, there's the button.
All right, I found my
so
button.
I put together this little website, losslesscontext. Is that what it is? Yeah, losslesscontext.ai, that walks through how this works, because it's not exactly intuitive. And this will serve as a good way to kind of introduce it. So, yeah, let's talk about how this works. So, this is how, if you're not familiar with it, which you probably are if you're watching this is how traditional context management works. It's pretty simple. And note that all the numbers in this are artificial and small in order to demo it. Multiply by 100 and you get real context windows. But the idea holds. And so with traditional context management, you've got your tokens. We'll say that there's a limit of 2,000 of them. We're at 660. We've got these two messages, and there's this threshold here at which point we need to compact, because when you compact, you need to reserve enough space to actually receive the response from summarizing all the previous messages. So as it fills up, it crosses the threshold. This triggers compaction. And what happens is all those messages that you had sent get replaced with a summary of the conversation so far. So it discards those original messages, and you're left with the summary, which does allow the agent to keep the general idea of what you were talking about intact, but it is a lossy thing, right? You have to throw a bunch of information out in order to produce the summary. And so let's talk about lossless now. Starts the same way. You've got this token budget. We've expanded it a little bit to give ourselves a little more wiggle room. Messages keep coming in, just like they normally would. And in lossless, we have this idea called the fresh tail. And we can do this because of the way lossless works, but we'll come back to that. And the idea is that there's a certain number of messages that we always keep around in context that we don't actually summarize. And so in this example, that number is 4. In lossless Claw, the default is 32. That's tunable. Just about every aspect of lossless Claw is exposed through config, and you can tune this however you want it. So the thing that lossless does, the first thing it does that's different than normal compaction, is incremental compaction. So we have our fresh tail here, and we have all these other messages. When those raw messages, those non-fresh tail ones, exceed a certain budget we configure, here it's 2,000. In actual practice, it's 20,000. In the background, so it doesn't block your conversation. It doesn't take 2 minutes like compact does. We asynchronously transform those, in this case, 2,000 tokens of raw messages into a summary. So just like normal context management, like we still are replacing those messages with a summary. But there's a catch, which is that this summary is backed by a row in a database. All the messages are backed by a row in a database, and they're related to each other in sort of a parent-child relationship. So we can retrieve them. We'll talk about that later. So now our conversation has one summary that summarized what used to be 2,000 tokens worth of messages into 320. That summary is here, and we still have our fresh tail of messages. So we still keep the exact thread of what we were talking about via the most recent messages, plus the summary of what was happening in the past. We keep going, and we keep generating more and more summaries. Now we have 2 summaries. You're going to see
But
this
this seems like
acronym.
a problem, Josh, because eventually you're going to have just way too many summaries.
It does. Yeah, that's right. What happens as you keep getting more and more of these summaries, they just keep growing. Okay, now I got 4 summaries. At some point, our conversation is going to get filled up with summaries, right? Well, that's okay because we can summarize the summaries. So once we hit a certain threshold of depth 0 summaries, right? That's these ones. They get condensed into a depth 1 summary. And by depth, you're going to see this DAG thing acronym all over the place. That stands for Directed Acyclic Graph. This is a computer science term. DAGs show up all over the place in computing. We didn't invent them. But the idea is that we have this tree, right? This summary has, points to all these summaries, which point to the raw messages. And so we build this tree that we can traverse that ultimately gets us back to the source messages. And as you move further up the summary tree, the hierarchy, you get higher and higher level of detail, lower detail, but more of a focus on the arc of what happened underneath it. So one thing worth noting is when we create these summaries, we use different prompts for the level that correspond to the level of summarization we're doing. So when we're summarizing raw messages, we're being more detail oriented than we are when we're summarizing those summaries. And so the further up you get, the more our summary is meant to capture kind of a narrative arc rather than the minutia of what happened at a lower level. So yeah, and you can kind of see that here. Like what I found, I've been using this for a month. I have around 25 million tokens in my OpenClaw session, and I have 3 D3 nodes at this point. So they correspond to roughly a week of time, depending on how active you're using. The D4s correspond to months, and this goes indefinitely, right? There's no actual limit to how deep the DAG of summaries can get. Okay, but what makes this actually work, right? Because so far, all we're doing is summarizing the same way that compaction does. But we just do it in the background so it doesn't block, and we do it periodically. And so your context is kind of constantly growing and shrinking as this background incremental compaction happens. We have tools that are used to traverse this DAG. And this is what makes it actually lossless, is that unlike with traditional compaction, where once you replace the source messages with a summary, the source messages are gone, right? You can't get them back. With lossless, you have tools that let you go and retrieve that source content in a smart way. So the first of these is LCM describe. This is the most basic. It takes a summary ID and gives back a bunch of metadata about that summary. It gives you what's in it, the content that describes what was being talked about, as well as this manifest that describes which other summaries it is summarizing and how many tokens are contained at the various levels beneath it. All of this information, like a lot of this information, at least like the summary IDs, these are captured in XML metadata in your context window. So the model always is aware of how it could go and traverse these because it has those IDs. And so under the hood, this is just doing SQL queries against a SQLite database to pull this information back out. The next tool we have is grep, which is exactly what it sounds like. It's just a full text search. over raw messages and summaries. And this is meant to be kind of a diagnostic tool for, okay, I'm looking for some detail about something that happened in the past. I have some keywords. Give me some pointers into where those are in my summary tree. And so you can see if we search for OAuth 2, it gives you, oops.
So that's kind of interesting and maybe a little bit different than what people might expect by default, because you're looking at this summary graph. You're like, oh, this is kind of a table of contents where you might need to crawl down from the top down to the bottom to find what you're needing. But the grep kind of cuts across the entire tree and can find information at any level of depth that's relevant, and maybe make you a little bit more efficient to find the information that you're relevant information for what the prompt is that the user has.
Yeah, that's right. And both of these tools, Describe and grep, are more utilities for the third tool. And let's talk about that one next because it's kind of the most important one. So expand query. This is the workhorse of the system that says, okay, all in this conversation, the only thing that's in context is this depth 2 summary. And it has an idea of what happened during that period of time and what information is contained within it, but it's a low resolution picture. What LCM expand query does is it says, hey, I've got a query. This is what I'm searching for. And I've got a prompt that I'm trying to answer, right? So I know, because of what's in my context, that we did some work on OAuth 2, per this example. And I'm looking for information about how we did refresh token. So you're going to search using refresh token. This is our prompt that we want to answer. And there's a cap on the number of tokens that it can return in a response. So what happens here, because we can't expand all the original source messages back into context because that would blow the context again. So what we do is we create a subagent. What it does, so the subagent receives this call. This call is what actually spawns the subagent, and it gets this query and this prompt, and then it is told, go and find the answer to this prompt. The subagent is what primarily uses describe and expand, right? So what it'll do is maybe call describe on this summary and see, there's 20,000 tokens in here. And it also tells it, here's how many tokens are contained within each of your summaries. So it uses that to make sure it doesn't blow its own context. So it can kind of intelligently determine how much budget it has to expand different things before it dies. And then it uses grep perhaps to go and find out, okay, I'm looking for a few different, I want to try and figure out which of these summaries underneath me to go and expand by doing a few searches. And so what it does is it uses those diagnostic tools to figure out how to walk the DAG, how to expand the different parts of this tree to find out what it needs to answer its question. And that can go all the way down to the original source messages. And then what it returns is a response that fits within this token cap back to the main agent. And that response is grounded in the exact source content that originally produced it, right?
So that prompts that the subagent gets, that prompt is written by the main agent, that's not the user prompt.
Correct. It's the agent itself that you're talking to that decides when it needs to go and perform an expansion. It's actually pretty good at knowing when to do an expansion. And the reason for that is that it already has summaries in its context that give it information about what is available to expand. So it has kind of like pointers to content that it knows that it can know more about if it needs to. You contrast this with, say, a memory system, right? Where a memory system is...
That's a good tangent, because a lot of people I know have written memory systems, or I see different memory systems all the time on X, and They seem to kind of maybe fill a similar void where you're trying to give your agents better memory.
Yeah. Yeah. This is a good thing to touch on. I think before LCM, memory systems are sort of all you have. And so what you like, at least the way it works in OpenClaw, which is modeled after the way it works for everywhere else, is you've got a memory system that you can store memories in. And it's got some tools that let it go and store those memories. For OpenClaw, it periodically writes information into memory files. And each day has its own daily memory file. And so it's up to the agent to go and say, something important just happened in the conversation. I'm going to go and write down a memory. And it does it. It goes and writes it. The only way that the agent can get those memories back out is by calling another tool. And how does it know when to call that tool? Well, it often doesn't, because it doesn't know what it doesn't know.
Mm.
And so with a lot of memory systems, you commonly find yourself saying, asking some question, and the agent goes, yeah, I don't know. I don't know what you're talking about. You say, well, go and search your memories. And then it goes and searches its memories, and hey, maybe it finds something there. But there's this annoying friction point where you have to tell it, hey, you should know about this because it's in your memories. But it doesn't know that it should know that, because there's not any indication in its context that it has ever had that knowledge in the past. There are ways around this to say, hey, before every prompt, go and run a search against your memory system to see if there's any matches. The problem with that is that you don't always want extra information injected into every prompt. Sometimes that information is outdated and irrelevant because it's old. And most memory systems don't have a very good way of distinguishing things that have been superseded by newer information. Other approaches are, okay, you just insert something about roughly what's in the memory database, but that doesn't scale so far because your memory system can kind of just grow indefinitely. And how do you decide what to go and put in there? So, LCM, Lossless Claw, solves for this because of those summaries that sit in your context. Over time, they get more and more low fidelity, but they keep kind of an overall picture of what was happening in the past. And just like with your mind, right, the things that you did last week are less fresh in your mind than the things that you did yesterday. Right? But the things you did last week, you have a better memory of those than the things you did a month before, but you still roughly remember, right? And so your memories get fuzzier and fuzzier as time progresses, but you still have knowledge of what has happened in the past. The summaries in lossless context management function very similarly. And so it makes it so that the agent still has this, progressively lower fidelity picture of the past, but it still has some idea. And that means that when you ask a question about something that happened way in the past, it knows, because it has these summaries, hey, that pattern matches against this summary in my context. And I need more detail. And I know, because I have these tools and I'm told via my system prompt, we inject that in Lossless Claw. We inject LCM specific information about how to use the tools. It knows that it can go and pull that information out using the tools available to it. And so it tends to be very good at using its tools at the appropriate time because it knows what it doesn't know, if that makes sense.
Yeah. Well, I know for me, one thing too with memory systems that's annoying is like the agent has to make the agent has to make a conscious decision to go ahead and store a memory. It's not like in this, like all your context is getting compacted. So I remember when I was first setting up my OpenClaw agent, one of the first things I did was give it a 1Password account so it could store its passwords. And a 1Password account has a master password. And so I did all this work to set up, Google integration and Twitter, and all these different integrations. And with all the credentials stored in 1Pass encrypted, And then the next day I go back to it and I'm like, okay, go ahead and log into Google. And it's like, what? I'm like, you should have credentials in your OnePass. And it's like, oh, I see the OnePass CLI is installed, but I can't open it. And I'm like, well, don't you remember your master password? It's like, I didn't write that down. And I'm like, cool, 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 buddy. Cool, very cool. So we're starting over from scratch. Um, that's the kind of thing that those kind of really frustrating interactions um, don't happen with lossless context because now it takes away the decision that has to be made to go and write to the memory banks. Like,
Yeah, the whole lossless compaction, incremental compaction, summary compaction workflow, that happens deterministically in the background. It's not up to the agent to decide when to go and summarize certain things. So you can rely on it to a much greater degree.
and correct me if I'm wrong here, but with the use of the grep tool, it seems to me that even if like some detail has been abstracted out of your active memory, like the highest level nodes that are in your context, like it can still probably find that if it goes looking for it. It's
Mhm.
sort of like if you tried really hard to think about like your second grade teacher's name. It's not something you remember every day, but if I sat here long enough, I could probably remember her name.
Yeah, that's right. One of the ways I think about the tools like grep is that, if I ask you what you were doing last Tuesday, you probably don't remember immediately. And so what you'd probably go and do is like pull up a calendar and look at other things that happened last Tuesday and use that to jog your memory.
Hmm.
grep is the same sort of thing. It's meant to, and the existence of the summaries, but the grep is sort of like it's a tool that's meant to help you help the agent jog its memory on what was going on. It has to be token deficient because we can't return tons of information when you go and call grep, because the whole point is to not blow your context all the time. So it gives you just pointers into roughly where to go and look so that you can then go and do a deeper dive, which is like kind of like stopping and thinking about it. I go and do my diagnostic stuff to jog my memory, and then I think for a few moments, and then I can
But
gradually recall all that information.
but if you do, let's say that you have pretty high level summaries like in your context because you've been using it for a while, and then you have to go back and retrieve some data using the grep tools or other tools that has been abstracted away. When you retrieve that data and use it to answer a new prompt, it's going to be in a lower level summary and probably more fresh in the mind because it's getting pulled into the more recent data. Wouldn't that work that way?
Mm-hmm.
Yeah. So like you're sort of now that piece of data, whatever it is in two memories. It's like it's in the memory of last
Yeah, the
Tuesday, but it's
fact that
also
you accessed it is also present in today's context.
yeah.
Yeah, the and how that gets represented in a summary is going to be different because it's a tool call. You're accessing some information. Well, the model that's doing the summarization knows that, and these things, they can be kind of smart, and they can distinguish between, hey, this batch of content was part of a larger batch of content about the implementation of this thing, which has got sort of a higher valence and importance for including in a summary than a question was asked about this work that happened a long time ago. Does that make sense?
Yes, it does make sense. Um, so I think a good thing to talk about now um, would be to um, maybe go into a little bit of the process of developing Lossless Claw. Like, did you use your OpenClaw while you were developing OpenClaw? Like, what tools did you use uh, to develop Lossless Claw?
Yeah. Uh, I did use my OpenClaw to develop it, which was at times painful because I was sort of having it perform brain surgery on itself.
Mm.
And sometimes that wouldn't work. I had one particularly annoying moment in which it lobotomized itself so thoroughly that it had no context from message to message. Yeah, and it did some annoying things that I had to undo as a result of that. But for the most part, I kind of had to develop it on Lossless Cloud because I needed an agent running this to be able to tell me if it was working and what was happening. And so the driver was OpenClaw running this. What was doing most of the actual development work was Codex. And so I have tools that let my OpenClaw run Codex agents that it can keep track of, keep beat on the state of, and check in with and manage generally. And so it was generally, I'm working on something within my OpenClaw on Lossless Claw on a particular issue, and saying, okay, this is a problem. Go and spawn a Codex worker to go and fix this. And then when it's done, you're going to go and take its work and rebuild and restart yourself, and then we'll test it once it comes back online. And that was happening in the background over the course of a few weeks, during a weekend trip with my family to the snow, and just kind of had it working on this in the background.
And you use the Codex agents because they're just that particular model, like the latest OpenAI model right now in the Codex harness is pretty effective.
Yeah, I prefer, like all the other OpenClaw maintainers, we have a strong preference for the code that Codex writes.
And they're not
Codex
paying you to say that.
They are not. No, I don't. No. It'd be nice, but no, they're not.
But if they wanted to pay us to say things, we'd consider it. But
yes. We would consider it.
But yeah, it's so having your OpenClaw agent run Codex subagents to do development. It's a good way to get high quality code, and using Codex at what it's good for, which is being in a coding harness.
Yeah. Now the way I've done this is sort of homegrown. This tool called Maniple that is MCP based. So I run an MCP server via LaunchD on my system, and OpenClaw communicates with it in order to manage Codex workers. And it can manage Cloud Code workers as well. But it manages these in the background, and it has MCP tools it calls to go and read their logs and check in with them and manage them and do things. There's a new set of features being developed by a couple of different contributors. The work builds on different work builds on each other, but I'm pretty excited about this. It's going to let through this protocol called ACP, which I think actually came out of the Z editor, but that OpenClaw now has very good support for. And
what's
better
ACP?
I believe it stands for Agent Communication Protocol.
Okay,
so
it's a way for agents to talk to each other.
Yep. And
so it's kind of like agent mail was like something I was using 3 or 4 months ago. I'm not using today, but okay.
Yeah, this is a little different. This is I haven't used it too much for reasons, but I've been seeing it, and what I gather is going to be coming very soon, possibly with the next OpenClaw update, maybe the one after it, is now from your OpenClaw you can spawn a codex, a running codex, but where the communication channel is from OpenClaw. So like I'm in Telegram, I can spin up a topic that corresponds to a Codex worker, and that Codex agent is actually sending all the messages it's sending in Codex back to my OpenClaw over Telegram, so I can just have a back and forth with it right from within the place I'm talking to OpenClaw.
Mm.
So
your OpenClaw sort of serving as an intermediary there.
Yeah.
Okay.
Yep. Which is the same as it was doing for me, but more indirect, where it's got tools it can use to inspect this external process. Now it feels like they're sort of getting merged into the same process. Not exactly, but it'll feel that way.
Cool. Another thing I think, like with multi-agent systems, is that you have to have you have to be careful that they don't like prompt each other in a loop so that they stay talking to each other forever. I don't know if ACP fixes that. Like you can't have two agents talking to each other unless if they are naively set up.
Yeah, I don't think this is so much the agents talking to each other as, although I could be wrong. I'll have to play around with it and find out. But um, it's more that the codex agent inherits the communication channel that you have over OpenClaw. So you can kind of, your OpenClaw is sort of like a proxy for all the messages happening in another agent. So you can interact with them in the same place that you're doing so with OpenClaw, which is one of the big value propositions of this project, is just access, the ability to work with an agent from your phone or whatever, over whatever medium you want to be working with it in.
You can go touch grass and be productive at the same time.
That's right.
Well, we're coming up on time here, but before we go, I think it would be fun to just talk about maybe some of the roadmap you're excited about with Lossless Claw or OpenClaw in general. Now that you're on the maintainers list, I know of OpenClaw and primary maintainer of Lossless Claw. Yeah, what are you seeing, and what are you excited about?
Yeah. Well, with OpenClaw, I'm excited for CI to pass again. We've been a big CI sprint and a whole bunch of work on plugins lately,
Doesn't
but
have like a massive CI suite on
it's insane.
OpenClaw.
Yeah, it's totally insane. I've got a M4 Pro with as much memory as they could give me, and if I run that test suite twice in parallel, it tanks the whole system. It's quite impressive. Um, the Okay, but what I'm really excited about, like I mean, I just mentioned this whole ACP thing and specifically the codex integration into it. I think that's the thing I'm most excited about with OpenClaw coming up. With Lossless on the roadmap, Lossless was released, I think like last week is when it started. At least people became really aware of it, and since then it's gotten, I think, 2.7 thousand stars. People are paying attention. And as a result, we also have lots of issues and community contributions. And so I've been adjusting to that world and have merged a whole bunch of things, especially last night. I'm about to do a big release that adds support for customizing different models to do the expansion process, different models for summarization than whatever the default one you're using through OpenClaw is. The ability to ignore certain kinds of sessions, like cron jobs that you don't want getting summarized, and a whole bunch of stability fixes that people have flagged and found and contributed. So it should get a lot more stable and a bit more featureful.
Are all those is all that customizable?
Yeah, everything is behind configuration options.
Okay, so like as people, that's cool. So as we actually get a community around Lossless Claw and people try different ways of using it, we'll get better defaults, presumably. Like we'll
Yeah,
find like different prompts that are better for summarization, or different models that word of mouth will go around saying use this model, not that model, for retrieval or summarization, and then the ability to exclude information from the context graph, things like that. Those all sound like improvements.
yeah. A couple other, higher level things. We're working on doing some actual evals of Lossless Cloud directly, see how it performs over long context windows. We found a few that are designed for this purpose, and so
Are
we're
there
working on
evals
that.
for OpenClaw agents?
I heard about one that exists.
Okay.
I can't remember what it is. In general, it doesn't seem like a lot, but that may also just be that I don't know of them.
Can OpenClaw agents run like coding evals for coding agents? Like,
They should be able to, because at the
yeah.
core of OpenClaw is just the Pi coding agent.
Mm.
So OpenClaw can code. We find it tends to not do quite as well as a more purpose-built thing like Codex, um, but it can.
I find, with a lot of in AI in general, just capabilities improve. So if
Yeah.
something can do something, then it can do it better eventually
Hmm.
as people figure out how to make that happen.
Yeah, that's right. So actual evals to track the performance now and track the performance over time. Those depth aware prompts where different prompts are used at different depths of summarization. There could be more dynamism in that. There's something called GEPA, which is a general purpose optimization technique for prompts that happens at runtime. That's something that Ted has been telling me for weeks that we need to experiment with. And I think he's right. And so that's what we're going to start doing once we get the evals done and then see, we'll have a way to benchmark our hard coded, opinionated decisions on what should go into different depth levels of summaries. But then we can tune that and see what happens when we play with different approaches. Those are the main things. There are other ideas floating around, but I'll leave it there.
All right. Well, the future of lossless context is bright.
It is indeed.
All right. Well, thank you, Josh, for your time. Thanks for talking about lossless context management with me. And follow us on our X, Josh or myself or Martian Engineering if you want updates on what we're doing. And just use our stuff. It'll keep getting better over time. Make your agents smarter, not dumber.
That's right.
All right.
All right.
Thanks, Josh.
Thanks.